Hello friends, today we will be talking about digital library architecture. The advancement in information and communication technology as well as the growth of information technology as well as internet has affected the design of digital library and its system. We will be studying several key components, design factors and key principles in this module. We will be also studying several models which have been implemented for digital libraries. We will be also talking about interoperability of digital libraries. We will be talking about interoperability of digital libraries. The internet and web technology are principal mechanisms deployed in a digital library to search, navigate and deliver electronic content across the globe. The digital content in a digital library can be made available through a single location or distributed across the network. A typical digital library implementation follows client-server architecture, as does the internet and the web technology. The online information search services like Dialog, BRS Search and STN work on host terminal technology, wherein hosts were huge mainframe computers that control all the aspects of search and communication sessions, and dumb terminals were connected to the host computer. A centralized server managed communications, user query interactions, database management and data presentation. The data from different sources has to be converted into a single homogeneous structure and organization. In contrast, enabling technology behind digital library provides for seamless access to heterogeneous digital objects created on different platforms and hosted in digital environment distributed at different locations on the internet. Let us see the client-server architecture. Client and server refers to both computer programs as well as to the computers. The client programs typically resides on users' personal computers or tablets, while the server programs reside on a server that hosts information contents. The server program and client program communicate over a telecommunication network using a well-defined protocol. The client program, or say web browser, is responsible for making a request to the server and for displaying the information it retrieves from the server. The server is responsible for receiving content from the client, controlling access to the information, performing the computation needed to retrieve the information, sending the requested information to the client after authentication, and handling the database management task, and in fact processing the request from the client. The middleware are computer programs that connect software components or applications on the clients and the server. The middleware resides both on client and the server and ensures that the client and server can communicate with each other irrespective of different hardware and software involved. This is made possible by use of standardization techniques of messages called protocols. The Application Programming Interface (API) is the middleware component that facilitates the transferring of messages between client and server based on the protocol. The API protocol defines a set of messages that are both client and server understand. The client's API translates the message into the form that is platform independent and transmits it to the server over the network. The server API receives the message and translates into a form that a server can understand. The server receives the message and responds to the client through its API. Middleware are used most often to support complex distributed application. It includes web server, application servers, content management systems, and similar tools that supports application development and the delivery. Now let's understand the key principle behind the design of a digital library. The major challenges in digital library design are caused by the differences in computer systems, file structure formats, information organization, and different information retrieval requirements of the collection, such as e-journals, e-book, reference sources, online courseware, GIS, etc., which are accessible through the digital library. While the web has emerged as a preferred media the use of standards and protocol makes it possible to make digital collection interoperable and accessible seamlessly. Some of the important features that should be considered while designing a digital library are as follows. The first one among them is open architecture, which refers to architecture or software architecture that allows adding, upgrading, and swapping components or software modules. Open architecture also allows potential users to see inside all the parts of the architecture without any proprietary constraints. Digital library design should use open architecture and set of well-defined standards and protocol so as to facilitate scalability and interoperability. The scalability, extensibility, and sustainability are three most important design features of digital library. The digital library design should ensure that a software should be able to handle large quantity of data and hardware, and the network should be scalable to handle large quantity of digital objects and its transmission over the network. Digital library design and planning should provide for human and financial resources required for sustaining the digital library on long-term basis. The digital library should provide transparent, seamless, and platform-independent access to distributed array of information sources to the user. The interoperability addresses the issue of ability of digital libraries and its components to work together effectively in order to exchange information in a useful and meaningful manner. Use of open architecture and a set of well-defined standards and protocol ensures interoperability among heterogeneous digital library in distributed environment. The Federation. Distribution of responsibility for content creation, management, and administration of various functions and services of digital library. It needs to be ensured that the participants follow the agreed standards, technologies, and tools. The architecture of digital library must ensure persistent and long-term access to its collection by means of digital preservation. The modularity is the design approach that adheres to four fundamental tenets of cohesiveness, encapsulation, self-containment, and high binding to design a system component as an independently operable unit. The digital library architecture should be platform independent both at hardware and software level. The digital library should be able to handle multiple files and formats such as unstructured and structured text, audio, video, images, graphics, animation, etc. The digital objects in the digital library should support location-independent identifier such as handles, PURLs, DOIs, and OpenURL. Here, the user interface facilitates to explore its collection. It also helps to conduct the searches. It provides interface for navigation through hierarchical menu of the subjects, and it also gives option for selection and deselection of searchable options and sorting search results. The repository service stores and manages digital object and metadata. The metadata that describes digital object to facilitate searching and discovery may be extracted automatically or created manually. A large digital library may have several distributed repositories depending on collection that it holds. The digital library developers interface with digital repository using Repository Access Protocol, that is RAP. RAP recognizes rights and permission to enforce intellectual property rights. The naming service. Digital objects in a repository requires location-independent unique identifiers or names. This identifier must remain valid whenever documents are moved from one location to another. A number of registry or resolver-based applications are being used currently for providing persistent URL to digital objects. These unique identification schemes do not directly describe the location of the resources to be retrieved, but instead they direct users to an immediate registry or resolver server that maps static persistent identifier to the current location of the object. The most used registry or resolver based applications are Perls, Handles, DOI and OpenURL. The process of indexing digital object involves linking of database of objects to a text database consisting of keywords and subject descriptors. Digital objects are required to be linked to the associated keywords and subject descriptors to facilitate their retrieval. A digital repository stores a large amount of unstructured data into two file systems for sorting and retrieving digital objects. The first file stores keyword or descriptors of digital object along with a key to second file. The second file contains the location of digital objects. The user selects a record from first file using search algorithm. Once a user selects a keyword or a descriptor from the first file, the location index in second file finds the digital objects and displays it. It is assumed that a digital repository has several indices and catalog that can be searched to discover information from subsequent retrieval from a repository. The search system and content delivery also makes a part of user interface. The design of digital library system should support searching on its collection. The search engine should support features like Boolean searching, proximity searching, phrase searching, etc. Most digital library software integrate external search engines. Now, while different digital libraries have their own underlying design and architecture, most of them supports component mentioned above. Some of the important digital library architectures are as follows. The Kahn-Wilenski architecture. Kahn and Wilenski in 1995 defined a general-purpose framework for distributed digital library consisting of very large number of digital objects comprising of all the types of material accessible over the networks. Kahn and Wilenski defined that the basic entity is stored, accessed, disseminated and managed in distributed digital repositories. Introduction of naming convention for identifying and locating digital objects in digital repository was one of the most important contributions of this framework. The DANS and NCSTRL architecture. The DANS, which is the synonym for server in German language, emerged as one of the first digital library architecture based on three basic principles of distributed digital library system, so that open architecture, federation and distribution. It was developed by Digital Library Research Group at Cornell University. The DIST model was implemented in the Network Computer Science Technical Research Library, which is available at www.ncstrl.org. The NCSTRL has more than 150 participating institutes and 20,000 digital objects. The DANS architecture specifies 4 core digital library service, that is user interface service, repository service, index service and collection service. The document model of DANS architecture facilitates 3 important functionalities that are considered important to any digital library design. These functionalities are unique document name, multiple document formats and document decomposition, that is physical and logical decomposition of a document. Interoperability among DANS server provides the user with single logical document collection, even though the actual collection may be distributed across multiple servers. This is accomplished by interaction between a set of DANS server at 3 functional levels, that is server registration, distributed searching and distributed document access. The NCSTRL has now moved from DANS architecture and OAI based architecture using ePrints for digital library software, and now it's powered by ARC for harvesting metadata. The CRADDL model. This was developed by Digital Library Research Group at Cornell University. The Cornell Reference Architecture for Distributed Digital Libraries, that is CRADDL, is component of Service-Based Digital Library Architecture. The CRADDL offers the following 5 basic services, that is repository service, naming service, index service, collection service, and user interface services gateways. As shown in this schematic, CRADDL defines a basic set of digital library service which interacts as shown. The design of user interface gateway can be customized for a specific community using mechanisms such as language, help facilities, and graphical aids. The user interface interacts with the collection service and facilitates access to one or more collections as desired by the user. This modular design of CRADDL allows easy integration of high-level digital library services, that is summarization service, payment service, and similar, with existing CRADDL service, or evaluation of existing service as the architecture matures. Now let's talk about the FTBS architecture and the NSDL. The NSDL and NDLTD are examples of digital library based on loosely coupled federated database system, that is FDBS, that are cooperating but are autonomous database system. Individual participants in FDBS continues their local operations such as defined by their own database system, DBMS. The FDBMS is the middleware software that controls and coordinates how the component database cooperate. The National Science Digital Library, NSDL, is a program funded by the US National Science Foundation, NSF, a division of undergraduate education. The objective of NSDL are to build a digital library for education in science, mathematics, engineering, and technology. The challenge of NSDL is to ensure that each of the collection and services developed under NSDL project is integrated as single coherent library, not simply a set of unrelated collections and activities. The technical agreement between NSDL participants is to decide on formats, protocols, security systems, etc. to achieve interoperability between collections and services. The content agreements to decide on data and metadata, including semantic agreements on interpretation of information, and organizational agreements to decide on ground rules for access, preservation of collection and services, payment, authentication, etc. The NSDL design attempts to achieve interoperability at following three levels, that is federation, harvesting, and gathering. Metadata from all the collection is stored in the repository and made available to provide NSDL service. The NDLTD is another example of digital libraries based on loosely coupled federated database system. The Network Digital Library of Theses and Dissertations, NDLTD, the digital library of theses and dissertations of master and doctoral students from various universities in United States of America and around the globe, has adopted federated design approach. The NDLTD team created an intermediate application that mediates search requests and had access to description of the search engine's user interface, the types of queries supported, and the operators that define and qualifies those queries. The NDLTD has also defined searchable database markup language, that is Search DBML, an application of extensible markup language XML for describing a search site. The federated search system distributes a query to multiple sites and then gather the results pages into a cache of browsing. Results are displayed for user without merging. The NDLTD has also developed a new metadata standard called ETDMS, that is Electronic Thesis Dissertation Metadata Standard. This standard is also based on Dublin Core. Now let's talk about CORBA. CORBA is Common Object Request Broker Architecture. It represents one of the widely known models of distributed object-oriented computing. The CORBA relies heavily on object-oriented and client-server technologies. it uses an open system approach. The application of Corba are platform independent both at hardware and software level. The process involved in Corba model of digital libraries is as mentioned below. The first one is IDL, Interface Definition Language. It defines the different type of objects contained in the digital library by specifying their interfaces. The interface repository IR stores all IDL definitions that represent the objects stored in digital library. Object IDs. Each object definition stored in an interface repository is given a unique object reference ID. With object ID stored in the interface repository, objects themselves can be stored on remote server. Corba supports requests for the service when the client knows specific object to be retrieved as defined by IDL. This is known as static invocation interface, and the client doesn't know the object IDs and wants to discover it. This is known as dynamic invocation interface. A proxy handles all the requests, either static or dynamic. The proxy process interface with the Corba infrastructure through ORB, Object Request Broker, and handles all the requests on behalf of client. The ORB is a middleware that connects the client and the server and allows object communication. The ORB locates the target objects residing on different servers and routes requests to them through message passing system. Software Agent Architecture and UMDL. The University of Michigan Digital Library Project UMDL uses a proprietary architecture to support the federation of loosely coupled digital library collection and services. The core architecture is concept of software agent that is based on object technology. An agent is highly encapsulated dynamic module of software representing an element of collection or services with very specific capabilities. The software agents are classified into following three groups. The first of them is User Interface Agent UIA. UIAs mediate the user access to the system. They convert queries and other user interaction into form that can be understood by other agent. UIAs create and maintains user profile that other agent can use to support searching. User profile are consulted by the agents to facilitate the delivery of SDI service. The next is Collection Interface Agent CIA. It mediates the access to collection, either full text documents, website or other multimedia objects. The major role of CIA is to provide registry with information regarding collection. They provide detailed description of content and structure of each collection. CIA describes the indexing system associated with each collection and how to search them, depending upon the syntax used. CIA also describes how to access the collection and what protocol is to be used for accessing the collection. The last one is Mediation Agent, MA. It manages all necessary tasks that support the system, such as those tasks that eventually direct a user to a collection based on specific query or user profile. MAs communicate only with other agents. The types of mediation agent includes registry agents to manage the registry and Remora agents that provides HDI service. Mediation agents are also assigned with the task of maintaining statistics of various activities. Task Planner agent in MA is responsible for managing tasks and other agents. Software agents communicate with each other using a proprietary language developed by UMDL called Conspectus language. The Open Archival Information System OAIS. For this, the reference model was developed by Consultative Committee for Space Data System CCSDS, and it was targeted to digital preservation project. It is basically a framework for understanding and applying concepts needed for long-term digital information preservation. This particular reference model does not specify an implementation and is therefore neutral to digital object types or technological issues. This model can be applied at a broad level to archive digital image files, bond digital objects, or even physical objects. OAIS has now been adopted as an ISO standard, ISO 14721:2003. The OAIS framework enjoys the status of the de facto standard in digital preservation. The OAIS reference model provides a high-level overview of type of information used to support digital preservation that can broadly be grouped under two major umbrella terms called, the first one is Preservation Description Information PDI, and the second one is Representation and Descriptive Information. The preservation description information consists of four major types of metadata elements, namely reference information, provenance information, context information, and fixity informations as mentioned below. The reference information enumerates and describes the identifiers assigned to the content information, such as that can be referred unambiguously both internally and externally to the archive, like ISBN or URN. Provenance information documents the history of content information, for example its origin, chain of custody preservation actions and effects, and helps to support claims of authenticity and integrity. The context information documents the relationship of content information to its environment, for example why it was created and relationship to other content information. Fixity information documents authentication mechanism which are used to ensure that the content information has not been altered in an undocumented manner by using checksums and digital signatures. The representation and descriptive information. Representation information facilitates proper rendering, understanding, and interpretation of a digital object's content. At the most fundamental level, representation information imparts meaning to an object's bit stream. For example, it may indicate that a sequence of bits represent text encoded as ASCII characters, and furthermore, the text is in French. The depth of representation information required depends on the designated community for whom the content is intended. Descriptive information metadata contains more ephemeral metadata. The information is used to aid searching, ordering, and retrieval of the objects. Here is the schematic representation of OAIS model, where there are producers, consumers. It involves preservation planning as well as administration backed by the management, the ingestion operation, and the access. Well, so far we have seen various models and principles of digital library. Now let's talk about interoperability in digital library. Interoperability is a critical problem in network environment with increase in number of diverse computer systems, software applications, file format, information resources, and the user. Digital conversation activities are distributed among the libraries that holds traditional print-based resources, and the digitized information is to be made accessible universally. Collaboration among the participants is therefore necessary in order to adopt a framework for achieving a suitable level of information sharing. Interoperability is ability of digital library components and services to be functionally and logically interchangeable by virtue of their having been implemented in accordance with a set of well-defined publicly known interface. In this model, various different services and components communicate with each other through open interfaces, and client can interact with them in an equivalent manner. The ultimate goal of interoperability is to create and develop the components of digital library independently and yet to be able to call on another efficiently and conveniently. Interoperability in digital library implementation addresses the challenges of creating a general framework for information access and integration across many domains. There are several approaches to achieve interoperability in digital library implementation. Following approaches can be considered to achieve interoperability. The first one is standardization, which is a proven approach to achieve interoperability. The standardization is the first one and proven approach to achieve interoperability. MARC and its different variants and Dublin Core are known standards for bibliographic description of the records. Z39.50 is known standard for information retrieval. The family of standard approach offers the choices of implementing one or more several standards. The ISO standard for Open System Interconnection, that is OSI, created an interoperability framework based on the family of standards approach. OSI in its 7-layer structures provide a family of standards concerned with given set of interoperability issues in the area of interconnection. In fact, the TCP/IP is also an OSI protocol. The specification-based interaction. Interoperability can also be achieved by describing the semantics and structure of all the data and operation. The specification-based interaction circumvent the requirement of mediation systems. Some of well-developed enabling technologies to achieve this goal include Agent Communication Language (ACL). The interoperability can also be achieved by deploying mediation machinery and interfaces for translation of data formats and interaction modes between the components. In the area of interconnection of diverse networks, network gateways play the role of mediation. Mediation interface can be designed to augment the facilities and the services that may search two digital libraries and present the result with own value addition. Such mediation facilities are called wrappers or proxies. Mediation technology thrives on standardization. For example, a single mediation system can cover all Z39.50 compliance sources at once or OAI PMH based sources at once. The mobile functionality consists of software agents that travel over a network to sites where they access the services that they need. These software agents reach back to their original site with the result of that works. Java applets and servlet facilitate such mobile functionalities that deliver new capabilities to the client components at runtime. Instead of depending upon standardization or third-party mediation, mobile functionality accomplishes interoperability by exchanging codes that facilitates communication amongst the components.